Okay, so we are going to complete day 3 of project 2. This is going to show us how to exploit Windows systems. So of course in the instructions here you might have a link, or your instructor would have sent you a link in Slack, but we need to register for the CTF site, just like what we did for day 1 and day 2, and you should end up with a CTF that shows Windows exploitation with post and all this list here. So once we have those, of course, we also need our lab, Azure Lab, was already signed in. In this case, I have both Windows machine, Windows 10 and Windows DC running. Sometimes they are not running, so you need to make sure that they are running, and Kali as well. So we'll start by connecting to Kali, because everything that we'll be doing in here, including our Google searches. So the username is root, password is Kali. Right, after that, let's start by reading what's going on here. For flag 1, it's under recon. Using OSCENT, search GitHub repositories belonging to Total Recall. So we're going to find out if there is any GitHub repositories. So the page belongs to Total Recall. We can search for Total Recall on all of GitHub. Total Recall, remember, is the name of the company. It's not a person. I mean, it's not a repository. So we do have these 2 repositories here. If you go to them, you will notice that they are empty, because they are just repository names. They're not the names of the users. If you look down here, it says users. You see that we have a user called Total Recall. So the difference between a user and the repository named, that was what was confusing there. And now we have a repository that belongs to Total Recall as the owner, and they have one repository called site. And what I like to do here is I like to look at the commit history sometimes to look for passwords, but I also am looking for hard-coded usernames and passwords here. And in this case, the old site, I'll check that one, but I see XAMPP users here. That's already interesting. And we see a username and password. It looks like a Linux username and password. I don't know if this is what we're supposed to see, but already I found something. And then we go here, echo, whatever that was. We need to validate and make sure that this echo command actually gets everything. To hash, I'm naming this user hash.txt. Let's verify, double check, and notice what it did. It actually didn't do it right. That's why we need to verify and validate that. Let me use single quotes. Sometimes single quotes preserve my data other than double quotes. That should do it. And notice that I just overwrote using the single sign there. Now that looks correct. So make sure you do that. And let's correct this with John. Alright, so the password is Tanya for life and the username is Trivera. Alright, what do they want from us? Search the repository for user credentials. The flag is the user's correct password. Oh, so the flag is Tanya for life. That's the flag for flag 1. Now let's go to flag 2. The Windows network has a subnet of 172.22.117.0. The flag is in a file within a website of an internal network. Use the credentials that you found in flag 1 to access the flag. Okay, so this is 30 points. So we need to go and scan the network first to see which other hosts they are, and then visit their site. So we need to run an nmap against that 172.22.117. Okay, let's keep the flag there, the password there. Open a new tab. Nmap minus. Let's do an aggressive scan. And we'll come back once we get the results, and we'll see if there is one of those things that is hosting a website. Okay, so after a while, we notice that our scan results are actually complete. And we found 2 machines here, WinDC with this IP address, .10, and Windows 10. And we are being asked to find one that's running a website and then use the password that we found to sign into the website. So where's the website? We're looking for website ports here. Looks like we get a hit here, or we are running Apache on port 80 for this host here. And that is our Windows 10 machine. So we're going to visit this port 80 and see what's happening on 172.22.117.20. So we go here. Is there a website there? Let's find out. See what it's all about. Advanced, accept risk and continue. The username and password that we just found here when we correct our password. So it's Trivera and Tanya for life, and our password Tanya for life. And okay, and once we're signed in, we see flag2.txt. So what we need to do is open that, and here's our flag 2. All right, once we've solved flag 2, we go to flag 3. Utilize FTP to access the file containing the flag. Okay, free hint: run an aggressive scan to determine the method for accessing this file. So I already ran an aggressive scan using -a. So we need to find out who is running an FTP server, and in this case it's our .20, and it says here login is anonymous. So we'll say FTP 172.22.117.20. Let's see if we can get in. So FTP, the IP address, the username is anonymous. Password is nothing, it's blank. So no password. There. Since this is a Windows system, we see that with flag3.txt. So we can say get flag3.txt to download it to Kali. Then exit. Cat flag3.txt, and that's our flag 3. So we have found 1, 2, and 3 from just enumeration. Now we're going to go to flag 4, which is Metasploit exploitation. Okay, so for flag 4, it says find a machine that is running SMail service, determine an exploit to run using Metasploit. Don't forget to set error host to the IP address of your local machine within the same subnet. Once you have exploited it, okay, find a machine that's running SMail. We just need to look through our nmap results. Whoever has a service called SMail, in this case, it's still the same machine, 172.22.117.20. Here's the service, version 5.5. To find out if we can exploit SMail, let's launch Metasploit, MSF console in quiet mode. And once Metasploit comes up, we'll search for SMail, maybe with the version, to see if there's any exploits there. Okay, so once a Metasploit starts, we'll say SL mail. Right, I only see one. The rank is great. It's not excellent, but it's great, and it's going after Windows machine, and 5.5 the version match. So say use 0. Then we'll ask it for options. Of course, set our host to 172.22.117.20, and our instruction also tells us to set our error host to the IP address in the same subnet, meaning our IP address for error host needs to be 172.22.117 something. So let's find out what it says here. In my Kali, IPA, grep 172.22. That should do it. So we know that now we are 100. So we need to set our error host 172.22.117.100. Exploit -J. Let's see. All right, there we go. We got Metapreter session 1. sessions 1, get UID. So we're in a system. That's awesome. Once you have exploited the machine, look for flag4.txt. Let's see. Do we have flag4.txt here? Yeah, right there. Cat flag4.txt, and we get flag4. So that was very easy. Now we'll move on to flag 5. Right, so you just gained access to Windows 10. What task should you consider doing first in case you lose access to the machine? Maybe you want to create a scheduled task like what we did in class that will automatically reach back to you. They also told us a hint: consider evaluating unnecessary scheduled tasks. So they're saying consider reading scheduled task. How do we read scheduled tasks? We can go and just ask Google because we forgot the syntax. How to read Windows scheduled tasks. Okay, so according to this blog post here from a simple Google search, you can say, hey, can you list them? And I'll put it right there. Give me a list of all scheduled tasks. Holy smokes. Okay, so we get a lot of results. That's just too many to go through. Let me do this with a /task name flag 5, or just flag star, but it should say flag 5. If the task has a name of something like that, let's just query for that and see. Okay, so the task actually exists. Now we just need to ask for all the information and be verbose and format it as a list. Let's see. Right, we get all the information about the task. Its name is flag 5. It's launching the ls command on this file share on C drive, on the C drive of the file share. Maybe it's monitoring, I don't know. So this number here, just the random comment, that's flag 5. So they just put a flag here, hoping that you pay attention and you read everything about the task. So flag 5 is right there. Now we go to flag 6. Continue exploiting the same machine. The flag is the plain text password of a specific user. Okay, so in order for us to dump password hashes from Windows, I think in our class we learned about Kiwi. So we can search our GitLab, Kiwi commands, credential dumping, this one. If we go and read this, in fact, it's right here. It says load Kiwi. We have to do this in a metaparator session. And then, of course, let's open it actually, so we know exactly what we're talking about. This is from the PS exec. So we're doing everything that's in these screenshots here. Load Kiwi. Then we would dump the cache. We're going to also dump the NTLM hashes and crack them using the same exact method from the here. So let's go and do that. So first, we need to exit out of here. Type exit. Load Kiwi in your metaparator session. So if you wanted to dump password hashes of specific users, there's two types of users: domain users and local users. Let's see if we can dump the NTLM hashes here first. And the one that we want to dump is this one. LSA. The DC sync would take domain controller information, and I don't think that's the one for here. All right. So this gives me the user NTLM hashes, which we can easily crack. In this case, I see a user called flag 6, and the NTLM hash is this one. So we need to go and crack this. File new. Let's echo using single quotes to ntlm.txt. Okay, that's my hash file. Now we need to use John to crack that NTLM hash. The format for John is, I think, is NT, So John dash format is equals to NT, then the name of the file, until m.text, and immediately we get the password of computer. So the user flag 6 is the password of computer that we were able to crack, and I believe that's what's being asked here. The flag is the plain text password of the specific user. So computer 1, type it here, and that's the flag for 6. Now we go to 7. Continue on the same host. Sometimes the answer is in public, plain sight. So we'll continue on the same machine. Sometimes the answer is in public, plain sight. What do they mean? Let's go back. Is the answer in the C directory? pwd ls. Is it in there first? Yeah. Wait a second. That's flag 4. And we're working on flag 7. So ls c. Let's see what's in the C drive. You know what? cd to C after we get into shell. dir. Okay, so it's not in here. cd users. dir. How many users do we have here? Is it in the public users folder, or is it in the dmd bob? It's somewhere in here. Okay, so since they said public in quotes, we'll look in the public. The documents. Okay, there's flag 7. Now we'll move on to flag 8. Using credentials you found on Windows 10 machine, laterally move to WinDC. Look for accounts on the new machine. In order for us to move laterally, we need to find some cached credentials for the users. Do something similar to what we did on day 3, the activity, the credential dumping. We just dumped the ones for ls dump without the cache. So what we're going to do is we're going to now dump the ones that are in the cache, that are cached, which is the people who signed in on this system, and see if we can get the ms2 password hashes and crack them. So first, okay, so we can just do an lsa dump cache. I think that's what it says here. Kiwi underscore cmd lsa dump cache, and we get some cached credentials, and right away I see Bob here is the only is the cache credential on the domain, and we have the ms2 cache. adm Bob means admin Bob probably, so I'll copy that. Let's go save that to file. Admin Bob .text, that's what I'm naming it. adm Bob, and the password, we have to do it exactly the way we did it last time, just like that. And then of course John dash format ms cache, and that to crack it. Control X, Y. When we get the file, we know that is there. So John dash format equals to, and we need to do ms cache 2 of the text. Let's see if we can crack it, and immediately we were able to crack it following the same exact steps that we took in class. So the password was change me and adm Bob. And what's being asked of us? Laterally move to WinDC. Let's use the one from the activity here. Alright, there we go. I guess we can use both WMI or psexec, it doesn't matter. So use exploit Windows SMB psexec. Psexec is better because then you don't have to wait for every command. So because of that, I'll come back here. MSF console. Now let's have a new one. File, new tab. Start it in quiet mode. So we need to use SMB psexec options. Okay, so we need to set our remote host. Everything that's required here we need to set as well. So set our host. So the remote host needs to be the IP address of the WinDC machine. Our WinDC one was 10. 172.22.117.10. Set our AO host to 172.22.117.100. Set SMB user. Our SMB user has to match the one that we just cracked. The name has to be exact, correct. Set SMB pass of change me without the extra space at the end there. I think that was it. Exploit, and that's J. Okay, sending the payload. Interpreter session 1 created. Sessions, there we go, and we are on WinDC. Sessions 1, get UID NT system. So what are we being asked on this flag? Look for accounts on the new machine. To look for accounts, we say net users, and we have flag 8. So the flag part is this one. We also have other users, but this is flag 8. So flag 8, done. Now we move on to flag 9. So this is a lateral movement. Continue to enumerate the new machine, and you will be rewarded with this flag in the heart of this file system. The heart of the file system is C. CDC there, and flag 9 type flag 9 dot text. Okay, so you just needed to know that the heart of the system is C. Now let's find the final flag, the password hash of the user administrator. Hint: look at day3/n to determine a method. This is the DC sync stuff that we did earlier, I think. So they said look at day3. We're going to look at day3 stuff. This is the DC sync dumping. Day3 credential access solved. So yeah, it's this DC sync here. So in this case, they're asking for the administrator in class. DC sync NTLM. After loading Kiwi, then they use administrator. So we need to get out of here. Type Kiwi in Metapreter. Load Kiwi. Okay, it's loading Kiwi. What commands can you run? DC sync NTLM, and the user administrator, which we found earlier. And sure enough, here's the NTLM hash of the administrator. Starts with 4 and ends with 82. And I think password here, the password hash of the user administrator. So that's the NTLM hash. And just like that, we just did every single flag on day 3 of the project 2. So